Hi everyone. The next type of integration involve inverse trigo. Okay, I want to integrate something that will give me inverse trigo. All right. So the first formula is integrate f prime x over a square plus fx bracket square. You get 1 over a tangent inverse fx over a. All right. So this formula, right, if you can recall under your differentiation, all right, when you differentiate tangent inverse x, okay, the formula is 1 over 1 plus x square. Can recall? Okay, so remember that integration is opposite of differentiation. If you integrate this, you will get back this form, right? Okay, so this is actually a very simple formula. So this is a more general one, right? Can you see that this is quite similar to this? These two are actually quite similar, except that my fx is now my x. Okay, so you can actually apply this formula when you see a x square below, and in the middle is a plus. Okay, on the other hand, for sine inverse, all right, in the middle is a minus sign. Can you see? Can you see the difference? Over here is a plus, while over here is a minus. Okay, but for minus sign, there'll be a sine inverse, and of course, there's a square root sign in front. Okay, so when you integrate f prime x over square root a square minus fx square, the answer will be sine inverse fx over a. Okay, you take this divided by this. Alright, so can you spot another difference? Alright, other than the minus sign and the square root. Okay, the third difference is actually this 1 over a in front, right? Can you see? There's 1 over a for tangent inverse, but for sine inverse, there's no 1 over a. Okay, so I think an example speaks 1,000 words. So let's maybe go through some examples, and then you can see better. Okay, so for example, I want to integrate 1 over 1 plus 4x squared. Okay, the first step is I need to compare between this and this, right? So what is my a? My a is 1, right? 1 is, because 1 is the same as 1 square. Okay, so you write as 1 square. Okay, 4x square is what bracket square? Ask yourself. Okay, the answer is 2x, right? Because when you square your 2x, you get 4x square. Okay, that's my first step. Okay, my second step is I need to make sure that on top is my f prime x. That means on top over here must be a derivative of the function here. Okay, do take note that your fx is this one over here. This is my fx. And not the whole thing, right? Not the whole thing, not the 4x square, right? This is my fx. So when I differentiate 2x, I'll get 2, right? So to do that, I'll need to times 2 on top. I'll need to times half. Right, once again to balance the equation. Okay, so once the numerator is the derivative of the fx over here, you can apply the formula. The answer will be half. Okay, 1 over a is 1, so no need to write anything. So tangent inverse, then fx over a, so it's 2x over 1 plus c. Okay, so the answer will be half tangent inverse 2x plus c. Alright, so this is how we apply this formula for tangent inverse. Okay, so what about for sine inverse? I want to integrate 1 over square root, okay, 4 minus 9x squared. Okay, so once again, I change this to this standard form. So I'll get integrate 1 over square root. Okay, 4 is the same as 2 square, right? While 9x squared can be changed to 3x bracket square. Okay, because 2 square will give me 4, while 3 square will give me 9. Okay, so in this case, my a is 2, while my fx is 3x. Alright, so this is my a over here, while this one is my fx. Okay, so differentiate 3x, I'll get 3, right? I need to make sure on top is a 3. So outside I need to times 1 over 3. Okay, so my final answer, alright, I can use the formula now. It will be 1/3. Okay, 1/3, because there's a 1/3 in front. Then sine inverse bracket fx over a, right? So it's 3x over 2 plus c. Okay, and this is my final answer.